All right, hello everyone and welcome. So my name is Ahmad Azab, and on behalf of the BASAR team, I welcome you to the BASAR seminar, which includes, of course, Barbara and Zana. So today's seminar will be 1 hour, including questions. So the first 45 minutes will be the presentation, and after that, we'll have 15 minutes questions. Of course, you can use the chat box if you like. So we are going to introduce our guest today, and I will pass it to Rahul.
Thank you. So, Sandeep Kaur Kuttal is an associate professor at the NCSU, North Carolina State University, where she directs the Human-Centric Software Engineering Lab. And her research combines the human-computer interaction, software engineering, and artificial intelligence. She focuses on the human aspects of software engineering by studying and modeling programmer behavior, and then designing and developing mixed initiative program computer systems. And Sandeep has recently received NSF Career and Air Force Office of Scientific Research Young Investigator Awards. And she has received the Best Paper Award at ACM CHI, the Best Paper at ACM IEEE ICGSE, and an honorable mention at ACM CHI. And she's on the editorial board of Journal of Computer Languages, vice chair of the steering committee for IEEE HCC, and acted as the chair or program committee member at a number of conferences, including CHI, LHCC, HCI, ICSC, FSC, ASC, and others. And she's very passionate about diversity and inclusion. Thank you for joining us today, Sandeep. Over to you.
Thank you for the introduction. Okay, am I audible? Okay. Yeah, thank you for inviting and having me here. And Rahul just introduced me. I'm Sandeep Kuttal. And today I'm going to talk about bridging programmers' collaboration. So basically there's something about collaboration here and gaps and how intelligent program-centric systems can help with that. But before I start with that, I want to kind of motivate the problem, and I cannot click. I think because of the Zoom, maybe sometimes maybe now, let's see from next time onwards. Okay, yeah, so if we think of software development, it is very human-centric. So humans are involved. I think the main difference between like all engineering disciplines is that in software, humans are involved even more than other engineering disciplines. And when I talk about humans, I think them as problem-solving professionals because they do problem-solving for their living. And there may be different expertise. That's what I'm interested in, like expert professionals who can be developers, like, working in industry, or novice programmers who can be students, basically, who are learning to program, and end user programmers, scientists who are writing simulation, physicists who are writing simulation to understand, like, their experiments. And there can be gender or race. In case of gender, I have looked at men and women, basically extreme ends of the spectrum. But again, like, gender is very fluid. So mostly when I say men and women, it is self-identified gender, what a person considers themselves as, like, whether a man or a woman. So these are the aspects which I'm interested in. And usually most of the IDEs which nowadays exist, they don't support software development or programming that much. So if we see, like, Norman's like gulf of execution and evaluation, there's a gap between the developers or problem-solving professionals and programming environment. In order to kind of like, give you an example, if you think about different expertise and just error messages, which is like very, very generic, like, thing out there. So in CHI 2021 study, which is pretty recent, when they analyzed the environments, what they found was for most of the people, reading error messages and their usability was very hard. it's still a problem. And it's like, 2021, and still we don't have systems which are very good. So which means very basic thing, which is like, how an interface should be evaluated from heuristic perspective, feedback from the interface, that is not even in a good shape. So giving an example for professional programmers, or basically expertise, at Google, there was a study in 2014. What they found was that 12 minutes on an average, most of the programmers spent just on confusing messages. And then such error messages had affected their bills 30% of the time. And mostly these poor messages, especially for professionals, are irritating. They affect their productivity, they waste their time. Similarly, for novice programmer or student, it's even more kind of harder, because these are cryptic error messages. They have to figure out how to solve them, and they may take even more longer time. So in one of the studies where they were doing eye tracking, they found that 25% of the time, the fixation of the students was on the error messages. And these poor messages usually kind of affect their, again, learnability, and they are not maybe interested in computer science at all, because this is so hard to solve for them. Similarly, for end user programmers in my own study, so this was during my PhD work. So Yahoo Pipes was an environment which allowed mashing up web contents. So it was a visual language which would allow, you can get contents from Craigslist or Realtor.com or maybe eBay, and combine and then do some kind of filters or some kind of content modification and show the output. So which was kind of programming, but for end user or web related people. And the error messages, as you can see, were very cryptic. As you can say, it's very hard for an end user to understand what does it mean. And basic principle of HCI is have a simple language. So I mean, still error messages. And in some cases, there was no feedback from the environment itself. Basically, there was no error message, and it was even more harder for them to understand what is going on. And mostly, according to the studies, very few environments support this kind of error messages, or even if the error messages they are cryptic. And in one study, they found that 76.3% of the time end users were spending on just debugging. And in my own study, we found in Yahoo Pipe repository, the mashups, or basically programs we collected, out of that 64.1%, they had some kind of fault in them, or some kind of problem in them. And they spent a lot of time in kind of finding the error and then fixing those errors. So this was an example, when the environment doesn't give feedback, nice. But what about when humans are trying to interact with the interface? So I will give an example from information processing styles and gender. So most of the programming environments, they provide selective information processing style. For example, here we have Java IDE. So usually what it means is when you hover over your cursor over a function name or something, it gives you explanation of that function. And there is then, this is usually men's problem solving style statistically. They like to kind of see one thing at a time. Then there is a comprehensive information processing style. What it means is the way the head example is, instead of just one function being shown, all the function which exist or a couple of functions can be shown at the same time. And this is called comprehensive information processing style, which is usually women like to do that. So in our study, when we did supported comprehensive problem solving style in Gidget, which is kids it's for teaching programming concepts, then women were more interested in learning to program. So just a small changes in the environment or IDEs can affect how the even education can be done, or what kind of community we can bring into education. So my research, it is kind of narrowing this gap down, basically between humans and the computers. Basically here humans, I'm saying, is problem solving professionals, and in bringing these software engineering techniques into their existing environments so that they don't have to struggle while solving their problems, especially programming problems. So I usually use iterative approach, since most of the people are from HCA community. They already know user-centered development, kind of conduct empirical studies, create theoretical propositions, and then design tools, and then evaluate them. So here, mostly my population user population is programmers or software developers, different gender, different races, and then understanding them, finding the problem what exists there, and then creating tools for them. So my research has HCI component, software engineering, AI, inclusivity studies. I do empirical studies. Also, I do a lot. So in this talk today, I will talk about three major work, which I'm currently doing, but most of my focus will be on inclusive pair programming agent design, and then collective foraging intelligence, and a little bit about gender effects and inclusive designs. So if you have any questions, feel free to ask anytime. So inclusive pair programming conversational agent, mostly it can be for programmers or it can be for students or novice programmers. So the idea is there are conversation agents all around us. So if we think of there are task-oriented conversational agents like Siri, Google Assistant, Alexa, and then there are social bots which allow socially or get connected with the systems or these agents, such as Cleverbot, Mitsuko, Zeus. And even 2/3 of the websites which exist out there, they have some kind of agents in them or conversational agents in them in order to kind of allow customers to communicate. So if we think of like most of our lives or most of in almost all domains, there are conversational agents, but there is no conversational agents for computer science, or we are in computer science, we don't have for ourselves. So that was the motivation behind this work. But if we start thinking about what kind of conversational agent we should have, like as a programmer, and what a futuristic conversation should look like, so I started looking at what are the software engineering methodologies which exist out there. So one of that is pair programming, which is agile methodology, where two people work together. One is the driver, another is the navigator. So the driver is the one who has control of the computer, and the navigator is the one who is looking at the code, giving feedback about errors or some bigger picture. And they switch role from time to time so that overall it balances out, everybody's working equally. And there is decades and decades of research on this in industry as well as academia, that pair programming is really good, as well as remote pair programming, in improving code quality. Code quality is the huge one, because two brains are better than one brain. So two people are looking at the code, that means the code quality will be better. It also increases confidence of each individual because they can feel better about their code. Somebody else also looked at it. It increases productivity because you can solve the problem faster. It narrows the knowledge gap because two people are also learning at the same time from each other. And there have been studies that it also narrows gender gap because women enjoy doing pair programming. So if we see, there are a lot of benefits of pair programming, but then also there are some disadvantages, or there can be, let's take a scenario. Tiana is a student or sophomore, second, third year, and she wants to complete her project homework. But because of COVID, she has to go back to her home, and people are in different time zones. So either in some cases, her classmate may not have same expertise as her. She won't want to work with them, or somebody may take credit of her homework, so she may not want to work them, or there may be conflicting schedules, or somebody may be giving harsh criticism. So there are some disadvantages of also pair programming. What if we have, instead of that, an agent which is designed to kind of help Tiana? So what we think is, if we have a conversational agent which takes the role when it is hard to do pair programming with other pair, or you feel uncomfortable, it can be created to be unbiased towards gender or race. So again, when I say, I will use it cautiously, because the data has to be equal. It should be gender equivalent, or it should be race equivalent, or we have to make sure that it is. So as human beings, we are biased. So in Nature, 2017 study, in Nature, it was when they they study the brains, and as soon as somebody sees someone, within 20 milliseconds, we make quick decisions about what we think about that person. So whether it is negative or positive, we immediately make, and even when we hear a phone call and we hear a voice, we start judging a person. So what we feel is if the agent is properly trained, maybe it will be unbiased towards other person's race or gender. So will be more inclusive. It can also be designed to motivate and encourage the other person. It can also be designed to have healthy problem-solving strategies. There are 5 problem-solving strategies, which we have done before in Idea Garden, which can be kind of integrated into these environments in order to help in solving. It can also avoid power balance, because a lot of time one person may take over or the other person doesn't want to work. So it can try to kind of keep them balanced. It will be non-judgmental, like I said, since it is not biased, it may not be judgmental about and give feedback and it will be actively listening to its partner. So these are the advantages we think it can bring, but there are still challenges. One, the domain of software development. It's different than whatever conversational agents exist, because it's mostly for reservation for hotel systems or like restaurants, those kind of, but for software development, people haven't thought about. And the user base is different, which is programmers. They have different kind of skills, they are not just doing conversations for reservation. They are talking about problem solving. They are talking about how to write the program and syntax. Then how the interface should be designed or how the interaction should look like with such a system. We have to also think about that. And again, in software development, there is implementation of code, there can be testing of code, refactoring. There are a lot of components which exist out there, and we cannot just start creating. So in order to kind of start thinking about, okay, we want to create this agent, the first step was, how should the design of such an agent should look like? So we started working on design of programming, such a pair programming conversational agent. So in order to do that, we started with human studies. We conducted pair programming studies of people. And based on that, we created a wizard. Basically Wizard of Fools is mostly a participant or human is interacting with the system, but the system acts as an agent, or basically responds. The interface looks like an agent, but the responses are from a researcher behind the door. But the participants or basically user thinks that they are interacting with a real agent, but it's the human being which is kind of interacting. So we conducted the Wizard of Oz study, and the Wizard of Oz study, basically how the dialogue responses should be, how the code should look like. That was designed from literature as well as human studies. So literature in HCI, software engineering, AI, psychology, education, management science, agent embodiment, intelligent tutoring systems, gender studies, and human-robot interaction. So from these different concepts, we thought about, okay, how the wizard should look like. And we designed, and then we also looked at what are the characteristics which can be transformed from human, and what can be transferred to human agent. For the design purpose. And then we, based on again feedback, what we got from Wizard of Oz, with smaller study with participants, again, we looked at the more literature, and we designed another agent design, which was a little bit more bigger and comprehensive. So to give you an idea, this is a Tokai paper, and there's a lot of detail. It's 40 pages long or something. So I won't get into details, but the main thing was there were 4 major components. One was interface. How should the face or looks should be? It should have 3D avatar, voice, text, gender, some kind of male, female, gender, human-like, and interaction, how it should interact with the human being. Then the other 2 components were, it should have technical skills and it should have social skills. So this was also based on our previous experience. So basically when programmers, or basically in software companies, software developers are hired, there are 2 skills they are looking for: technical skills as well as soft skills. So technical skills is basically how good are you at writing code or test cases, or whatever kind of profession you're looking at. And the soft skill is also you should be motivating, or you should be able to collaborate, so those soft skills should also be there. So we created the agent design, like, okay, these should be the design guidelines we have, how the agent design should look like. Then so basically we created the whole this design. So the next step was, okay, we are saying that we want to have this agent, but will this agent work? So the next study was, we wanted to look at the feasibility of such an agent, that if such an agent is introduced to humans, will they be able to pair program with it? So, so what we started was, the main idea was, can we continue the benefits of pair programming by replacing a human programmer with an agent? So that was the bigger question we had. And we conducted 2 studies, human-human studies with 9 pairs, and then human agent studies. And these all were gender balanced studies with 14 pairs. And as you can see, the p-value, and as I said, the advantages of pair programming is productivity, code quality, self-efficacy, confidence in your code. So we looked at those components. It is not significant. So which was good news for us. That means we can introduce such an agent. It may have the benefits of pair programming. Few things we noted. Again, this is a long paper, and I have compressed everything into one slide. So what we found was human partners trusted agent, and this is kind of a problem everywhere, that humans usually trust agents a lot, and these were programmers. Even then, they were trusting the code because they thought it is bringing the code right, and which may have implication for ChatGPT and stuff, like, you know, when they're getting the code from ChatGPT or Copilot, they may trust it too much and not want to change it. And especially for students, if not for developers. Human partners interrupted agents. It was easy for them to interrupt another agent, not another human, because there are social, like, you know, things which they have to think about. They didn't modify or refine agents' ideas, or basically the code agent gave. But when it was humans, they would think about it or modify it. Agent partner was unable to explain. So that is coming to explainability AI, that the whatever solutions there are, like, you know, as a driver or as a navigator, should be able to explain it also. So okay, it's again not moving. Okay. So a few things. Another thing, we also looked at creativity strategies, which is Osborne's Parnas, like, you know, this framework, which is basically when people think about problems, or especially in programming also, it is a creativity problem. And they think about, first they clarify the ideas, then they think about they clarify the problem, they think about the ideas, then they develop the solutions, and then they implement them. So when it was human-human studies, what we found, they were sequential, like, you know, they will start with clarify, then think about the idea, then they will develop, then they will implement it. But when it came for human agent, they were all over. So they would switch between the phases. It wasn't sequential. And what we found was that mostly for clarify and develop, the percentage was like 25% or equivalent. But for idea, they were thinking about less ideas and doing more of implementation with agent. But with human, it was like equivalent. So again, like I said, like ChatGPT and all, like, you know, those kind of environments may affect the creativity, even in intelligent tutoring systems. So we have to think about that when we give them code, it shouldn't affect their, like, you know, creativity or idea generation. So this was, and then once we had, like, you know, the feasibility, we knew that, okay, this kind of agent will work. So the next was, will machine learning algorithms be able to understand the conversation a programmer will have? Because the programmer conversations are a little bit unique. They may talk about variables, they may talk about the file names, like, you know, or code or test cases, which is a little bit different than like, you know, restaurant booking and stuff. So if we think of this was mostly natural language understanding, when two humans talk with each other, it's much easier to understand their nuances. There is, like, you know, whole body language you look at in order to understand. But when it comes to the computer, it has to have very, like, you know, kind of definitive conversations so that the intent of that speaker can be understood. So for this, like, we use DialogueX in order for natural language understanding of the conversation. So DialogueX is used in mostly with most of the conversational agent like again, they have been used for more than 10 years. So in most of the conversational agent, that's what they use. There are few of dialogue acts which we used. This is like abandon, acknowledge, answer no, apologize. So we looked at the human-human conversations, which was 3,436. When I say utterances, or what it means is every sentence they were talking with each other. So every sentence, between 2 people or 9 people, was 3,436, and we used all of them and we labeled them with these dialogue acts. And then we looked, if we see the dialogue act utterances, they were statements was a lot, but then they were also answer no or apologize, which were like less numbers. So what we did was we also used class weights. What it means is that when there is no class weights, the data can be more and less. But if there are balanced class weights, then all data is same. That means the number of conversations for where it was 17 or 24 was increased and statement was kind of reduced or something, so that everything is kind of labeled. So in AI techniques, this is used a lot when the data is less. And we used SVM, like simple model in machine learning model, to kind of understand whether the feasibility of using any machine learning algorithm. So the results were there was 57.91 accuracy when there were no class weights, and 54% with balanced class weights, which kind of shows that, okay, we can use machine learning algorithms. And if you see, here the accuracy of statements is more because these colors are darker, while here this becomes these colors are a little bit more darker because the diagonal one, because overall the correctness was kind of increasing. So the other, we also looked at, if there were conversations, if there was no class weights, then the conversations were more accurate. But recent context, what other person was saying or that same person was saying, was better judged if it was balanced class weights. So since it was a machine learning algorithm, there were features. So we looked at first 10 features, and these are the 10 features. And what we found was either it was 41% was contextual, but this is the most important one, that 11.67% was only domain specific words. So which means related to, this was a tic-tac-toe game. So as you can see, this is current player, column, those kind of conversation, which was specific to that domain, was only almost 12%, which is not huge if we think of from English perspective. So, so there was still disadvantage. One is nascence in dialogues. Other is we need large corpus, more data. Then only we can train, because there are apologies was only 17, no answer was 21. The data is less. We need more data, and especially for deep learning algorithms, if we want to use them. So still there is larger problem, which is collecting data, because that's the most important. Then only you can train these models. So for data collection, one way is you conduct these lab studies. But we also thought the other way is we have these pair programming conversations on YouTube and Twitch. What about them? Maybe we can also use them, online videos, and we transcribe them and label them and then use them for training purposes. Another is generating labels for pair programming conversations or programming conversation, because these conversations are unique. The label needs to be software engineering specific instead of those dialogue acts, because dialogue acts is different. Maybe some of them can be used. So what we did was we created a new classification of software engineering specific labels. So some of them were, the gray ones are from dialogue acts, which already existed, like uncertain, thanking, answer, feedback. But as you can see, there are only 4 or 5. But all other are very specific to programming. Here, we use both human-human conversations and human agent conversations in total, and then we label them with these classifications. And then the next step we did was, the next step is to implement a programming conversation agent, but we did the first step, which is NLU, basically understanding the conversations. For that, we used BERT. At that time, there was GPT-2, GPT-3 wasn't there, or 4, and XLNet. So we compared these, and as you can see, mostly the accuracies were almost similar in the conversation. They were predicting almost same. But rather, actually, BERT had little bit more, 0.2 2% or something more. So we used BERT mostly later on. But as you can see, like overall, the accuracy is higher than SVM, as well as because these models are already trained on English language, so and domain-specific words were less. So basically, we can use these language models also for understanding. The other, like I said, there are already videos existing. So we wanted to also see the feasibility of those. What if we use those videos for labeling? And because one, we can have more data, which may have different domains and also different languages, because that's the hardest part, getting data in different languages, different domains, so that there are more rich conversations. So what we did was we used a BERT model here. We looked at what was the accuracy between human agent studies, like how the accuracy looked like. It was 68.38% if we use BERT model. And then we used, for human, it decreased to 55% for same labels. But then we use transfer learning, which means is you start with more data, then you fine tune it with less data. So if you think of BERT model is kind of trained on all English models, then we train it just on human data. Then we train it on human agent data, which will get fine tuned. And then the accuracy kind of was equivalent to what, human agent are a little bit more. In other, in AI, it is like 0.2% more or something they have found in their data. So basically with transfer learning, we can increase the accuracy. So if we think of what we can do is, so we started with the YouTube, and I will explain here. So we started with YouTube, the accuracy was like, as you can see, 45% only, 46%. And then we did transfer learning. We trained it on YouTube, then human data, then human agent, kind of fine tuning. Then the accuracy increased to 68.79%. So which means if we use transfer learning, we can kind of use the BERT model, then train it on YouTube data or Twitch data or online videos, and then with lab studies to kind of fine tune the model further. We also looked at the gender differences between human agent. Men showed more uncertainty with another human than an agent. So basically they trusted agent more. So these are some of the conversations they had. Men gave more direct and indirect instructions to another human partner than an agent, again, kind of trusting more. And they gave more positive feedback to their human partners. While for women, apologized more to human partner than an agent. Women made more statements while working with an agent, so it seems they were more comfortable. They used more direct, indirect instruction with an agent than with a human, again, kind of more comfortable, like saying to another agent than a human. They were positively responding to an agent. And so this is overall architecture for a conversational agent. So we have done the NLU component, which is natural language understanding. Then is this whole dialogue state tracking, which is called dialogue manager, and dialogue policy generation, and then responding, which is still, so we think Copilot or ChatGPT, kind of if it integrates as a backend and it gives the code, maybe we can create a better, we have to test it, I'm not sure about that. But initially the idea was that in software engineering, there are based on UML, based on whatever code exists, either we take the database and then give that's what ChatGPT is doing. So that's why maybe we can use that. And these components need state tracking, reinforcement learning, and some kind of interaction with the third-party software. So this is what in future we want to do. The other thing we want to do is automate test case generation, because yes, these ChatGPTs and stuff can do the code generation, but test case generation also, it automatically generates. And there is a lot of work on automated test case generation, code generation at level of statement or function also, which is still kind of and explain, like I said before, explainable AI kind of to give the feedback. So these are bigger. So the second project is collective foraging intelligence. So here the idea was, if we think of as a group, we are more knowledge, each individual has different kind of knowledge and intelligence, what if we combine it together and tap into it? So that was the bigger concept, but it is about foraging. So taking the example of software development is mostly global activity. So software is being developed everywhere, the teams, they work at different places, different locations, and they work kind of different developers, and the team size may be different. For example, they may be working on the same code. Maybe they are creating a browser, and one team which is kind of when they create that browser, it is collective intelligence of the team. And another team, maybe of 2 people, is creating a browser somewhere else. And third team, or there are different teams creating different kind of browsers, which are kind of distributed across continents or time zones. The knowledge is kind of spread across. So that's what the idea this is trying to convey. And as a developer, when developer is also writing the code, their sources or how they are writing the code is kind of distributed. There is IDE, where they are focusing and writing, then they have to go to maybe Stack Overflow to find error or code, or GitHub to get the code, or maybe on the web to read blogs and all while they're writing the code. So this whole knowledge is kind of distributed, and so much knowledge, or some of trying to get into so much knowledge is called information pollution. There's so much garbage also, which you don't want, and also information overload, because it's a lot of information, and then they have to kind of go over each information and then kind of get it. So that costs both time and cognitive effort. And this is the information seeking problem. They have to seek for this information, going through all this vast amounts of data. So what if we use information foraging theory? So information foraging theory is from biological sciences, which is already used for creating interfaces as well as in programming. So here the idea is there is a predator, so which is a programmer. They are looking for a prey, which is an IDE or maybe Stack Overflow or GitHub, whatever environment you want to think. Prey, which means it's an error, or the piece of code you're looking for or information you're looking for, that is your prey, because that's what you are trying to find. Patch is Stack Overflow or IDE. And then there are cues, basically animals look for maybe paws in the sand or some kind of sense, but for us it will be maybe bolded text or some way of kind of looking at information. Or the variable name is kind of named in a way we want to, it's easy to kind of understand what it is. So the whole concept of information foraging is that even for animals, they try to decrease the cost and increase the value. So they will prefer to have a bigger, prey to eat rather than a smaller prey, so that they can have more value or more energy to consume in less time, but they can also grab easily. So the same thing, humans will also like to have more valuable resources and in less time. So, so information foraging theory, I have used it before. One for debugging web-based environments. So when I was saying about Yahoo pipes, so those environments looked at when they are debugging, how do they look for error and how they try to fix the error. And based on that, created a model for debugging. Then also for same variant of programs, which we called variant foraging theory, which means is the same program may have different variants. All the program, maybe the colors are different, the way the text was written is different. So that is variants of same program. The code is same. Maybe there's some very changes to that. And we created a PFIS-V model and PFIS-H model. And then online repository for end user programmer here, looking at how do they reuse their code in online repositories. And we looked at MathWorks and App Inventor, which is Android app development environment. And we created a reuse model. So basically, in the past, it has been used, but mostly this has been used for individual programmer, not for the teams of program. So when it is about programming concept. And as I said before, in the environment, mostly things work together, like waggling the of bee or ants leave their pheromones. What if similarly, these teams which are working together, they are leaving their logs which maybe we can grab, or there is a way we can record their logs so that we can understand how they are browsing, how they are kind of looking at these different things in order to understand. So that's what the idea of this is. So we have done a little bit work. We operationalized IFT, which means like for Stack Overflow as well as GitHub also we have done, but operationalized it like IFT concept. What is the value, what is cost of different pieces in Stack Overflow, and we labeled that, created a model. It was like, you know, the way we did was we looked at all this data, and then we created hierarchical clusters and using distance matrix, what is high value, low value, and then created a regression, logistic regression model, and then looked at generalizability, if that was same for Python also. And we also have conducted some user studies to understand, lab studies as well as interviews to understand how foraging works in these different environments, Stack Overflow, GitHub, as well as web. And these were gender balance studies with the students as well as professionals. So still we are working on like operationalizing IFT for all these environments. And the idea is we want to create a model which is more generic and which can take information from these and kind of like, you know, which is IFT based, but it is for social kind of team structure. Like, you know, it can give recommendations to the person like, oh, this piece of code will be better, or this is how this user or expert has used it in the past and maybe it will be helpful. So that kind of, and then maybe first do it for programming and then maybe for generic model. So that's what the idea is. The last one is gender effects and inclusive designs. So I just have one slide, but I will talk about like what we have looked at. So for here, what we have looked, we conducted a lab study, and here we had same and mixed gender pairs. So mixed gender pair, a man and a woman, extreme, again, spectrum, a man and a man, and woman and woman. So what we found was for leadership, authoritative, when there was a mixed gender pair, one person would, doesn't matter who the, like what the gender was, but somebody will become authoritative. When it was same gender, they would be more democratic, which means they were balancing out there, like, you know, nobody was taking over. Primary communicator role. So when women knew things, they wanted to be a navigator. And when men knew things, they wanted to be driver. They wanted to write the code if they knew that. Remote technology preference, women preferred in person, men were indifferent, they didn't care whether it is online or in person. Communication, women used a lot of nonverbal cues. As you can see, these are two women, and over time, this was 40 minutes task. When two women were talking, there's a lot of nonverbal communication is going on, smile, laughter, confusion. And this is a woman, so again, there's a lot of, but for men, it was a little bit less. And in other communication literature also, they do say that women use more non-verbal cues like body language and facial expressions to kind of convey what they are trying to say. And in other literature also, like emojis and all, they try to use more emojis in their texts also. Then we conducted, like based on these results, we created a survey, and also from other literature, those questions, quiz questions and all. And so what we asked was that, so there were these pairs, we divided into the pairs. So basically this person, if it is like, you know, this person filled the survey, but they filled for another woman. So basically they were answering the questions whatever perceived gender of that person was. So one is self-identified gender. So this person, and they were filling out for somebody they thought was a woman, and they were saying things or answering questions accordingly. The same for the other one, men thinking about another, they are filling for another man. So what we found was for leadership, women said that men dominated the conversations. Women felt another woman was giving them more constructive. So these were statistically significant things which we found. And women asked more help from another woman. And women felt they were interrupted by men. Difficult online communication, women felt it was harder to communicate with another woman, and men felt it was harder to communicate with a woman, and maybe nonverbal cues can be explanation for that. Men felt women used a lot of nonverbal cues. Women felt men make a lot of gender-based assumptions. and men said other men, or basically peers, statistically they said the other person or man was more rude to them, and women felt men were giving them hurtful feedback. So these were like overall like statistical results we got for two. We are still working on the main idea is we want to create a methodology, a persona for helping that in product we have we don't have any gender inclusive bugs. The other is also kind of creating a facilitator conversational agent which can help in efficiently allowing the collaborations between two people of different gender. So in the past, I have worked on end user programmers. So I won't talk much, like 2-3 minutes, which is solo. So who are end user programmers? They can be accountants who are creating an Excel sheet, scientists who are writing simulations in MATLAB, engineers who are writing code in LabVIEW to simulate a robotic arm, students who are learning to code using Scratch, teachers who are teaching code using App Inventor, or web designer using Yahoo Pipes in order to create their programs, or homeowners who can be using to create their own intelligent devices. So they are end users, like almost everybody is end user programmer with phones and stuff. And in 2000, usually if we think of, there are less number of professionals and there are more number of end user programmers out there. And this is like 2005 study where they said that, oh, there are 3 million professionals and 90 million. And now at this time, I think the numbers has increased tremendously, exponentially rather. But professionals have some kind of tools, but these end user programmer don't have those tools. So I have created tools in the past for end user programmer. One was Pipe Plumber, which helped them in keeping kind of history of whatever code they were writing, whether it was tested, were there in bugs, so that it is easier for them to kind of find errors. Debugging Sport, which was for mashups, basically had explanation with hints, like where they can find the answer and what kind of error is there, explanation on that. And then also kind of showing the history or lifespan of a project, like who has copied, how many errors it may have, or where the error develops. So this red bars show that, okay, these codes have errors, so maybe you can skip them. That means this error didn't go transfer to other code. But there was error in that. So by looking at it visuals, you can easily select one of them. And Idea Garden, this is the problem solving one where different problem solving techniques were kind of integrated. So these are my collaborators from industry and academia, and my students and some undergrad students who have authored paper in red, and funding agencies. And yeah, so I use iterative approach for developing tools and understanding professionals, programmers, or problem-solving professionals. And yeah, that's pretty much all. I'm happy to take any questions. Thank you. Yeah.
Thank you very much. If anyone has any questions, you can ask. You can use a chat box, so you can unmute yourself as well if you have any questions.
Sure. Okay.
I guess the question maybe everyone will ask is, what does ChatGPT and GPT-4 mean for all of this work?
Can't hear. 1 minute.
Oh, sorry.
Yeah.
Sorry, we couldn't hear you. Can you repeat the question, please?
Oh. I can keep it in. Judy, can you repeat your question, please?
Okay, can you hear me now?
Yes.
Okay, so I'm just wondering what GPT-3 and 4 and Copilot mean for all of this.
So I don't see them interfering, rather they can be supportive. So because till now what we are talking about is conversation, like what here in conversational agent is that can communicate with another human. So which means like, there can be physical limits also, like if a person cannot hear, like, hear properly or not hear, sorry, like, you can have kind of conversation with this agent, but ChatGPT is more like it is just a search based, it just you search the text and it gives you code related to that. So which is different. And I don't think that is, yes, there is, like, I'm also looking at that actually, interviewing professional programmers and trying to understand how do they use ChatGPT and what they are doing currently. But ChatGPT will be more as a backend that needs to be integrated. So not this whole conversational agent or pair programming conversational agent. Does it answer the question?
Thank you.
Okay, sure. Yeah.
So I have a question. So the typical way that I use ChatGPT is compile a program, copy the error message and ask it to solve syntax error for me. I wonder if is the better strategy, applying IFT or another thing that I can use in these cases.
So that it seems like we should work on that, like such problems. But to some extent, yeah, it is information forging problem. And what ChatGPT does is trying to do that thing. That, it is trying from all the information pollution, trying to find you a recommending you a solution which is better. But what you are explaining is more human steps. Like, can I reduce those human steps in order to get a better answer from ChatGPT? Which is a different kind of problem. So, like, which means like, that how we can write the queries. And again, like personally, like I know that a lot of people like don't speak the language, for them it will be really hard to kind of use those kind of tools because they are English based. And that is whole research problem itself, like, how you're going to kind of get solutions, because that's what we want to understand. What are the problems when I say interviews? What are the problems or strategy? But you just explain the whole step, because it's when you ask the question, what you have to do is you have to think about the bigger picture. Then you have to make it smaller tasks, and then you have to even more so that you get very specific solutions from it, which needs a different kind of strategies and thought process, which means our education system needs to be differently. So that's what, like, I personally think needs to be done. And that's what we are trying to understand, but I'm not sure, like, at this time we have answered for that. But thank you for the question. Okay, with a sufficient competent agent, especially one that will understand contextual information, for best cases that perform code reviews, the end result of this be two agents in pair space and remove human interaction, given a sufficient strong specification that is. I didn't thought about that. Thank you. That's a very interesting question. But that's a very interesting question. Like two agents interacting with each other and then solving the problem. That wasn't the motivation. But I suppose, like any other science, the things can be taken in either direction or anywhere. But that's a very interesting question. I'm trying to think. We shouldn't remove the human, because part of the reason, like, why this agent was designed was to help humans write the code, and especially those who don't feel socially comfortable interacting with others. But like what you just said, I never thought about that, like, yes, there is a possibility that agents can interact with each other and try to solve problem, but I mean, it won't have any educational value or productivity value to it. But yes, it can be done. And I think I need to like a little bit think more about it, like, how can we stop that? Use all the movies you see about the ethical perspective of agents. Like, I don't think, like, when we have technology, that should happen, because we want to use technology for good and not for bad. But thank you for the question. That's a pretty interesting question. I never had that question before, so thank you for that. It always makes you think more whenever you get these kind of questions. But yeah, ideally, like, till now, yes, the conversational agent was thought more from educational perspective, but you never know, like, people may try to do that, taking two agents and they are interacting with each other. And I don't know what the results will be, or how will it look like? Or maybe it will be beneficial, maybe like, how the interactions happen. Maybe two humans, a human is learning as being a facilitator person and trying to learn how these agents interact. But I don't see much value in that. I feel like one-to-one is better, but I cannot answer this time about what that will look like. Yeah, thank you. Do you have any thoughts, or do you want to say anything about it? Okay. Yeah, I mean, it would be interesting, like, what is your perspective on it? Yeah, thanks for the question. Any other questions?
I was wondering if you can comment a little bit about the gender related stuff, because I found it very interesting, and also I wasn't aware of some of the differences how men and women work. Also, looking at the comments in the very last slide, there seems to be the assumed biases playing there. So how would interacting with an agent could possibly influence the way we think, because we can always assign a gender identity to an agent, right? That's something.
Yeah. So I will answer this question in two parts based on my research. So one, when you asked about gender identity of an agent. So when we conducted human agent studies, at that time, the way we conducted was we also wanted to see effect of agents' gender, on how the two genders also. In our studies, what participants said, like what we did was that we changed the gender of the agent halfway. So it was a 40-minute study. First 20 minutes, like we again did equivalent balancing. The first time they had a male agent and then a female agent, and then the other time it was female agent, then male agent for half participants, so more balanced overall. But most of the participants said they didn't even notice that the gender of the agent changed the halfway between. They were just too much into their code and writing. They didn't pay attention to that. So it seems like till now that both gender cared about the gender of the agent, but we can make that selection. Like they can select what kind of agent it should look like, what kind of voice they want. But when I say about conversational agent because this is again we are in HCI, we don't just give things to people, we study people and then we kind of improve them. At this time, what I think is, personally, I feel all human beings want to be good people and try to help each other. There may be implicit biases, but they don't want to do it. So what I see it as is, what if we kind of just educate them? Because we don't want, if women are more nonverbal cues and men don't use, we don't want them to start using nonverbal cues or women to stop using it, because they should be doing what they are used to do. But maybe just educating this person is this, and that's why. Just understanding that this person is behaving in a certain way, why they're behaving, I think that will be just more like educational, that okay, this is why they're doing. And still we have to see how does it affect? Will they kind of improve over time? Will they help them understanding the other gender better? That's why communication is happening in a certain way because of that. So that's what personally I feel the interface should look like, because we don't want to kind of change their behavior. We want them to be comfortable the way they are doing, but being aware of why their partner is behaving in a different way, so that the productivity or when they're working together, it doesn't go downhill, it goes uphill, or at least it stays. So even if it stays, that's a huge, I think, at this point. Okay, there's another question. Okay. In the library program, we find in software design construction. The challenge is pairing one case is how to pair the same skill sets to and therefore the agent will be helpful. But at the same time, with pairing with agent, the student is getting to work with a computer rather than a real man in the study. Yes, there can be, it can be a negative effect that, okay, they may get comfortable working with an agent too much that they don't want to work with humans, like the way nowadays after COVID, people just want to stay home and not like, come to like students, especially come to the classes. So yes, that can happen. But like, I think, again, all these things like needs to be kind of carefully kind of given because yes, there can be a negative effect also. I won't deny that because like all these things may have some kind of negative effect. But at the same time, especially like people who have hard time, I see it as a helping tool that how to communicate or what kind of dialogues they can use or how they can communicate with another, like even if it is agent, like but at least communicate, like the sort of time, maybe when they are really starting with a human, they are not even able to communicate or say, at least once their confidence is built or they know how to communicate with agent, they will be comfortable doing with another human. That's what like my thought process was when like we're thinking about it, because communication is a very important aspect in software development that they need to have in order to kind of develop very strong or efficient softwares. But that's a good point. But I personally feel it's more like it will help in educating, but I cannot say until implement it in classes and see what happens. But till now, I saw it more as an educational, that it will help in learning how to pair program with another person. And then, or maybe it should be in class design. You start with that and then you pair them with another human. And then see how the efficiency of things go. But thank you for the question. It was pretty good. Yes, Rahul.
So you're of course interested in human interaction, but I was wondering on the other direction, or the current GPT-3 and 4 and others, what persona they take seems to influence the kind of or the kind of interaction they provide. I wonder if your research on humans can be applied to these things to make them better.
Of course, I think like so at this time these agents are just like these models which are fine-tuned, even for me they don't know what these things are doing. So the only way an agent persona can be that maybe those characteristics are fine-tuned to certain aspects, like I was saying about for pair programming conversation, you fine-tune for pair programming, humans or human agent, like or maybe for specific domain or language, or maybe some characteristics also, which will be kind of separate from like when I said about the conversational agent, it has interface interaction, that is the persona it can take, but in the back end it is ChatGPT. So to that extent, that's what I will say, because again, these agents are just algorithms and like even nobody knows how they are coming up with all the solutions, but solutions are too accurate. So it will be hard to kind of like, pinpoint what is going on. But the persona which you just mentioned, what I see as is the slides in conversation agent when we were talking about design, with interface, traction, technical skills, social skills, depending on what we mean also, because if we are creating the conversation agents for doctors, it will be very different from what we have for like software developers. So accordingly, like creating the person. Yeah.
I think we don't have any further questions. Thank you very much for joining us, everyone.
Thank you,
Thank
everyone.
you very much, Sandeep, for this presentation. And we'll see you next week and next seminar. Thank you, everyone.